Hello all. In the previous video, we have discussed about searching an element in a linked list and finding the length of a linked list. In the previous video, we have implemented the search functionality using iterative logic. In this video, we are going to see the recursive logic. We'll implement the recursive search function. Let's start. Let me take a linked list. 30, 40 and null. This is my head. In the previous solution for search functionality, which is an iterative solution, what we did is we took a current pointer and we have changed the position of current pointer as current equal to current.next until we reach the null, and for each and every iteration we are comparing it with the data. So like for search function we will receive the data, right? The data which we want to search, we'll compare the data with the data of this node. Okay, whenever we find that data, then we'll return true. If we don't find, we'll return false. That's how we have implemented the iterative logic. In case of recursive logic, we are going to traverse the linked list in a different manner. We're going to traverse in a different manner. How is that? I'll consider this as my current initially. So what we'll do is my recursive function, first what I'll check is whether my current dot data is same as this data or not. If it is not same, what I'm going to do is I will call the same recursive function by passing current dot next. By passing current dot next, it means we'll be here. So I'll call the recursive function with head, that is current initially. Current will be head. I'll start off with head, and if we don't find the data, we're going to call the same function by passing current dot next. By passing current dot next, and we'll do this until we finish the linked list. So let me write the logic for that. What we'll do is I'll call this search. So this time I'll get the data. One more thing which I'm going to take is the node. I'll call it as current. The node, I'll call it as current. In case of iterative solution, we just took the data and will search. But now this is a recursive solution. So what we are going to do is we'll start off my recursive solution by passing the head, that is the first node, and we'll check the condition whether it is matching with the data or not. If not, what we'll do, we'll call the same recursive function by passing current dot next. So first I'll start off my function by passing, let me write over here. So how am I going to start is, this is my, let's say this is my main method. In my main method, what I'll do is I'll say list dot search, and I'll pass the data. I'll pass the data and also the head. I'll pass the data and the head pointer in the first. So the control goes here. Now here what we'll do is, for the first time we'll get head, right? What am I going to do is I'll check whether my current dot data is equal to the data which I am going to search, this data. If it is equal, then I'll return true. So this is one of the base condition for us. Is one of the base condition. Okay. There is one more condition which we have to add. We'll add that. So next, let us say we are going to search for 30. We are going to search for 30. We have started with 10, that is head. 10 is not equal to 30. So I'll again call the same function. By passing the data, which is the same data, and this time instead of passing current, I'll pass current dot next. So ultimately we are moving to the next node, right? If we see here, we are saying current dot next. It means my current is moving over here. It means for the next function call, it will start from here. My current will be here, right? Now here I'm passing current dot next. Yeah. Now let us say we haven't found the element. Let us say I'm searching for 50. I'll come here, 20 not equal to 50. I'll again call this 30 not equal to 50, 40 not equal to 50, and current dot next will be null. It means we haven't found the element, right? In that case, what are we going to do? We need to add one more condition. That is, if my current is equal to null, then I'll return false, right? I'll return false. This is the overall code for searching. Now let's take the example and let's write the function call for each one. Okay. So what I'll do is I'll take the example again. I'll take 10. I'll take 10, 20, 30, 40. I'll take this example. Now my head is here. Okay. First call I'll do from my main function, that is search. The first call is search. I'll pass the data I want to search, let's say 30, comma, my head node, right? This is the first call which we'll do from the main function. Okay. Now for first call I'll pass the head. It means right now we are passing this to my search function. So the search function will be like search. The data I'm going to search is 30 and head is 10. The data is head is 10, right? So what we'll check? We'll check if current, this is current, sorry, not this one, this is data, and this is current. We'll check whether current equal to null, and we'll return false. So in this case there is some value, it means there is a node, so this condition doesn't apply. Next I'll check if my data at current dot data is 10, current dot data 10 equal to 30, to return. This condition also gets failed, right? Because 10 is not equal to 30. So what we'll do, we are going to return, I'll call the function again, search, data is 30, This time I'll pass current dot next. What is current dot next? That is 20. Current dot next. This one. Here my current was here. So current dot next will be 20. Right? This time I'm passing 20. Now let us start a fresh function call. Now this time, now we are here. Now again, one more function call. First thing, I'll check if my current is null. Oh, sorry. I'll check if my current is null. We are here. Current is null or not. This condition don't apply because we have some data over there. Again, I'll check whether my current dot data, which is 20, my current dot data, which is 20, equal to the data which I'm going to search is 30. No, data is not equal. This condition gets failed. What we'll do? We will do the same function call. The data is 30. This time current dot next. My current was here. Now current dot next means this one. This time it is 30. So again I'll check if it is null. No, right? Condition fails. That is current. Okay. Now I'll check if my current dot data is 30 and the data I'm searching for is 30 and return true because we found the data. Since this condition is passed, we will return true. Will not go for the another function call. Will not go for another function. So here true is returned. It means here, okay, let me write it over here. Here true is returned. So here also the value will be true. So here again return true. So here the value will be true. Again here for this function call which we made from the main will get true as the result because we found the element. Let us say we are searching for 50, then we don't find the element. So in that case we will go for the next element. Then the next element in our list is 40. The next element in our list is 40. 40. Yeah, 40. So I'll pass the data. Okay, data. Let's say data I'm searching for is 50, and next element is 40. Okay. Again, not equal. So again, I'll go to the next current dot next. This time 40 dot next is null because 40 is the last element. So while searching, for the next function call, I will receive here data I'm searching for is 50. 40 dot next is null. I'll get null. So we'll check whether current is null or not. If it is null, we'll return false because we haven't found this element. Okay, this is just in case of element that is not found. Okay, this is when we found the element in our list. Now let us code this. This is the overall function. Okay. I'll implement here public boolean. I'll call it as search recursive. It will take data along with the node. I'll call it as current. Right. So first thing we'll do is we'll check whether my current equal to null. These are the base cases. current is null means we have reached the end of the list. It means we haven't found the element. And if my current dot data is equal to the data which I am searching for, then I'll return true because we found the data. Or else what we'll do is we will search for the next. It means we'll take the same data here. Instead of current, we'll pass current dot next, recursively call the same function but with the next node. Done. Now let's run this. So here I have 4 elements in my linked list. I'll run this again. I have 4 elements. What I'm going to do is I'll call list dot search recursive. We have to pass the data I want to search for. I want to search for 30 and the head node, right? Pass list dot head. Now if I run this, so if we see, we have got true because 30 is found in the list. If I say 50, which is not present in the list, and run it again, you see we got false because that is not present in the list. This is how we implement recursive search. Here we can do one thing. Here we are passing the head, right? So what I'll do is create a function public boolean search recursive. It'll just take data, and it'll call the same recursive function. Just overloading the function, I'll pass the data and head because here I can directly access head. Instead of passing the head from this main function, it is better to handle it in the logic so that we can just call recursive search of 50, no need to pass the head explicitly. So here again I'll say return done. So here what I'll do, now I'll not pass this. Let's test it again. So we got false, 50 is not present. I'll try with 40. True, it is present. Yeah, just overloading the parameters of the method. So if we pass only one parameter, obviously this function gets called and it will call the search recursive function which will take the data and the head node initially. That's it for this video. Thanks for watching. If you like this video, hit the like button and subscribe to the channel. Thank you.